Hello. Thank you, Christine. My name is Nikhita, and I am a co-founder and chief product officer at Artificial. And our goal at Artificial is to make automation more accessible in the lab. So if you go to a typical lab today, this is a picture that we've seen happen over and over again. When we first started Artificial 3 years ago, we went and visited about 100 different labs, all the way from startups to folks that had many, many automated systems. And the reality is that when you start implementing automation, a lot of the equipment isn't connected to the internet, so it's really difficult to have remote visibility into your lab. There's a ton of interfaces that you need to learn in order to be able to go from an experiment all the way to data in the cloud. And if you look at this picture here, there's a ton of paper and Post-its that are attached all around the system in order to actually teach someone how to use it. So our goal at Artificial is to make this a little bit easier and build a single software platform so you can go from an experimental request all the way to result in the cloud without having to leave a single interface. The way we do that is 4 core applications, and at the bottom is what we call our editors. So one of the first things that a customer told me when I walked into a lab was that if you've seen one lab, well, you've seen one lab, because they're all very, very, very different. And so we built this set of editors so that each customer could tell us a little bit more about what makes their lab unique. So with our lab editor, you could go in and build a complete digital twin of your lab environment and tell us all the equipment that you have, how your TCAN or Hamilton runs, or how everything is positioned in the environment. With our assistant editor, labs can go in and take all those paper SOPs and all the Post-its and put them into the digital world using our markdown language to describe all the steps that operators and scientists need to do. And with our workflow editor, you can go in and stitch together all the manual steps and the automated steps into the processes that you want to run. Layered on top of all of that is what we call our LabOps application, which is really a single command center to run everything in your lab and request work to happen from anywhere in the world. So I wanted to walk through our vision for how a scientist or operator interacts with automation and equipment in their lab. So what you see here is I can go in and see all the labs that I have. We've named them after Disney in different places because I know everyone likes to have their own theme in the lab environment. And you can see all the experiments that are running, what may need your attention, what progress is currently being made, and you can go in and request new experiments to run. From there, you can go in and use our scheduling engine to optimize when that work should happen. So you can look in the next day, weeks, or months and figure out the best spot for an experiment depending on the availability of both people and the machines in the lab environment. From there, we use our digital twins to walk each user through exactly what they need to do to get that system ready for a run. One of the things that I think is really true is that on the boundary of every automated system, even if it's a TCAN or a larger system or a Hamilton, there's always a human interaction to load everything up and put all the reagents and plates and tubes in order for the run to happen. And so this gives users a really simple way to walk through every step, know what they need to do, and how much of each reagent or plate or tips they need to load into the system for the specific run. From there, an operator can go and watch the experiment happen, and they can monitor it from the lab itself or anywhere in the world. You can just log into Artificial and see on that digital twin what's running, if anything needs assistance, if anything's in error, and take action on it as a lab manager, as a scientist or operator or automation engineer within your lab environment. So in this case, there might be someone sitting in a completely different place, interacting with that lab and figuring out what they need to do next. When all of that is done, it all comes together into a data record, which is essentially a single source of truth of everything that happened in the experiment itself. So we show you all the automation steps and how the equipment ran, if there was any errors or logs or things that came off the system. We also show you when all the manual actions happened and if a person had to fix something or if there was an error. And so you can really come here and see all the results and exactly what happened in that experiment, so you know how to answer questions like, should I redo this experiment, or should I quarantine this data, or take action on what's next? Bringing it all together, our goal is really to bring these 4 core users onto a single platform. We want scientists and operators to have tools in the lab to run experiments day to day and be able to leverage machines and automation at scale so that they can create more reproducibility and larger sets of data. And then we want automation engineers to have the tools to onboard new systems and be able to deploy automation at a much faster pace within their lab environment. And finally, we want lab managers to have the tools to know how their automation's doing, what utilization they're getting out of it, and how to make things a little bit more efficient. Thank you guys for listening, and if you're interested in nerding out about robots or automation, you should come visit us at booth 29 or visit our website at www.artificial.com. Have a good rest of your conference.